I will start out by letting you all know that the test was going to be on Tuesday instead of Monday. Therefore, if you have any questions left over, you can ask me on Monday, which also means all of the Chapter 1 homework needs to be in the folder by Tuesday. Check Infinite Campus to see what you have turned in and what you don't have turned in, and see if I've made a mistake, because all of the grades are right now updated in Infinite Campus as of yesterday afternoon. Also, I've put the set of notes that I'm about to go over in your folder, as well as the homework assignment, so you may want to look through that, although I'm going to pretty much do most of it on here anyway. So the first example, number 1, is we are going to make a relative and cumulative frequency graph for the time that it takes to get ready for school. So we have our data, and so I'm going to make, this time instead of using 5 or 10, I'm going to make each interval equal to 12. So for the relative frequency, this will be very similar to the histogram, and for the cumulative, it will not be, as we are going to continue to add up groups of people until we get all the way up to all 100% of the people. So my first group is going to be everything in between 0 and 12, not including 12, which is going to be 1 out of the 33 people, which gives me a percentage of about 0.03. And for the cumulative, I have the same numbers, which is 1 out of 33. Now as I go from 12, not including 24, we have 4 out of 33 in this group, which is 0.121. But for the cumulative, I now have 5 people, all who take less than 24 minutes to get ready for school. So my cumulative goes up to 152. 24 to 36. And of course I made a mistake counting, so this should have been 5 out of 33, which is the 0.152. And this should have been 6 out of 33, which is 0.182. Sorry about that. And then from 24 to 36, we have 9 out of 33, which turns out to be 0.272. And for this group, we are at 15 out of 33, which turns out to be 0.455. (36 to 48). For the next group, we got 8 out of 33, which is another 0.242. And that means that over here we have 23 out of our 33, which turns out to be 0.697. (48 to 60), not including 60. We have 0, which is 0, and so this is still 23 out of 33, which is still 0.697. 60 to 72. 6 out of 33, which gives me 0.182. And so now we are at 29 out of 33. .879. 72 to 84. Had 0. I mean 1. Which is 0.03. So 30 out of 33. Equals 0.909. And then from 84 to 96, had 3 out of 33, which is 0.091, and 33 out of 33 gives me 1. So that is our frequency table and our relative and cumulative frequency table, and now we have to turn them into a graph. So on this page I'm going to make the relative frequency graph. So 12, 24, 36, 48, 60, 72, 84, 96. And so this is time to get ready, and this is percent of the people. And so since we're only going up to 0.024, I'm going to make this 0.05, 0.1, 1.15, 0.2, and 0.25. So 0.03 is there. 0.152 is there. 0.272 is there. 0.242. I don't know why I made the first one blue and the rest of them orange. 0. 0.182. And 0.03 and 0.091. And this is your relative frequency. It looks just like the histogram. If we would have done number of people, shape would have looked the same as long as we made the intervals the same. So for the cumulative, I'm going to make another graph. The bottom still time to get ready, and the vertical axis should be percent students under time. And since we go all the way up to 1, I'm going to make this 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. So 0, 12, 24, 36, 48, 60, 72, 84, 96. And so we're going to start out at 0, 0 because no one takes less than 0 minutes to get ready. Then we went to 0.03, which is still kind of low, and we connect the dot. And then we go up to 0.182, which is about right here. Then we go up to 0.455, which is about right here. Then we go up to 0.697. Then we flatten out at 0.697 for a moment. Then we go up to 0.879. Then we go to 0.909. And then we get up to 1. So this is a cumulative frequency graph, also sometimes called an ogive. And basically we can take a look at this to see what's happening. If you have a steep slope, that means that we have a lot of people. Quick point about these cumulative frequency graphs. Since there is a small amount of data down here, if we see a graph that looks like this, this would be considered skewed to the left. And here there's a little data up here, so this one would be considered skewed to the right. If I ever get the straight diagonal line, this would be considered something that's considered uniform. And if we get something like this, this would be what we would normally have as our symmetric. If I was drawing the histogram for this last one, it would be our normal one, the modes in the middle, and we have stuff on both sides. So here is an ogive that is dealt with ages. And so if I want to do a 50th percentile of the ages, what I'm going to do is I'm going to take my 50% line and cut straight across, and then I'm going to go down. So the 50th percentile in this case would be about 41, it looks like. So that would have been my answer for part A. What is the percentile for a 35-year-old? I would go up here and go over. And so my answer for part B would be the 30th percentile, because that's the y-axis. So for part C, when it asks for what is the 80th percentile, I go across the 80th line and go down as best I can to find out that the age looks like it is about 50. So I get an answer for C of about 50. And then for D it says what is the percentile for a 55-year-old. So I go straight up on the 55-year-old, and I went a little bit too far. And it looks like it's just short of that 90-degree mark. So I'd probably say that is the 88th percentile for that graph. Alright, the next thing we have is the z-score, which I have defined as the number of standard deviations above or below, if the answer is negative, the mean. So the formula we have is going to be for the z-score is going to be the score minus the mean divided by the standard deviation. So let's take a look at example number 3. Given that the mean is 125.07 and the standard deviation is 136.4, what is the z-score for 0? So since the score is 0, and I subtract the mean, which is 125.07, and I divide by 136.4, the answer turns out to be, making sure that you put these in parentheses, negative 0.91. What is the z-score for 480? 480 minus 125.07 divided by 136.4 equals 2.60, which means that this one is 2.6 above because it's positive. The negative from part A means it's obviously below. In example number 4, we're going to do the same thing. We have a score of 21, which is the age. We have a mean of 40.89, and we divide by the standard deviation of 6.8. So this would have been negative 2.925, so we call it negative 2.93, or for the age of 56, 56 minus 40.89 divided by 6.8 equals 2.22. Now we use z-scores to compare things that are different on scales. So in example number 5, we have Mr. Freelieb's test has a mean of 70, so I'll put down that the mean is 70, and the standard deviation is 6, and that's for Friedlieb. For Fader, we have a mean of 75 and a standard deviation of 5. So if a student scores 80% on both tests, which one did he do better on? So the z-score for Friedlieb would be 80 minus 70 divided by 6, which is 1.67. The z-score for Miss Fader's class would be 80 minus 75 divided by 5. And that would give you a z-score of 1. So comparatively, since getting a higher score on a test is better, comparatively, even though you got the same score on both tests, you really did better compared to the rest of the class on my test. We'll do this one more time with example number 6. The average man has so for men, the blood pressure is about 140 and the standard deviation is 6. For females, the mean is 130 and the standard deviation is 8. My blood pressure is 150, so the z-score of myself is 150 minus 140 divided by 6, which is 1.67. The z-score for Mrs. Friedlieb is 140 minus 130 divided by 8, which is 1.25. Who should be more concerned? Well, since high blood pressure is bad, I should be more concerned. Using the same data, what happens if my blood pressure actually was 100 or Mrs. Friedlieb? So I do 100 minus 140. So this is the z-score for Mr. divided by 6. And the z-score for Mrs. is 100 minus 130 divided by 8, which is negative 3.75. Who should be more concerned this time? Well, once again, I'm going to say me, because if you have 6 standard deviations over 6 below, then this means that I'm like almost dead. Although Mrs. Freelieb should also be concerned because 3.75 below is probably not normal either. The homework, if you can't open the homework document in your folder for today, is 1, 3, 5, 9, 13, and 15 on page 100.